Hi, everyone. It's a pleasure to be here. My name is Frederico. I'm the founder of Immerso. We make software for construction and property development, and I want to share with you some of our work today. We have a lot of cool things to show you. I'm going to talk about the concept of digital twins. Can I bring my slides up, please? And this idea of digital twins, I'm sure most of you by now have come across in one way or another. There's a lot of flavors to this. In our world, we mean it literally. We want to have a digital twin as a copy, a replica of what's going on out there at the job site. And that's our idea. And the concept is very, very simple. If the on-site reality and the documentation in the building plans match each other at all times, there's love for everybody. For the owner, for the contractor, for the suppliers, the consultants, everybody collaborates better. Everyone's on the same page. So how do we go about making this happen? We've created an online platform that first plugs into your building plans, represented there as your Bim models for your project, and sets those up as the performance targets, because by definition, that's what your plans are. And then we've made software that allows anybody to use 3D scanning technology with one button, which means you can do this as simple as taking a photo. Anybody can do this. You've never done it before. You can get started in a few minutes, and in a matter of hours, you've captured an entire building. You can do it as frequently as you like throughout the construction phase, and the data is uploaded to the platform, giving us the most accurate documentation of the as-built status with millimeter precision in full 3D. And now the idea is that if the project is on track, then the data we see from the scans should match perfectly with the documentation of the building plans every single time, right? How often do you think that happens? Right, big round number. Never, never. It never happens. But better yet, there's always differences. There's always mismatches. If everything is on track, the computer finds everything green. When things are missing, potentially delayed, misplaced, built with the wrong dimensions, the computer flags those and reports to the relevant team leader so they can resolve the issue early with minimal impact to the project. And we think this is a huge opportunity to change the current scenario of the industry, which is what we see here over and over. We see a huge investment going into the early stages of planning and design, creating these beautiful models, optimizing all the disciplines, clash detection, energy efficiency of the building. And why? Because the better you plan, you minimize risk, and the project will definitely go according to plan. But that's not reality. When the construction phase starts, there's no system in place to methodically check if what's getting built is actually going according to the plans. All of that is done today manually, in-person inspections with the photos and spot checks and the schematics. There's no way to keep track of tens of thousands of moving parts. So things are going to go overlooked and rapidly snowball into costly problems. That's how you have costs, downtime, delays, disputes. The owner at handover is going to get a building with documentation that doesn't really match what was built. And that's terrible. If he has to maintain this facility for decades, imagine you just bought this massive machine, complicated and very expensive, right? And you can't trust the user manual. You wouldn't accept that with your fridge at home. And I love that quote from McKinsey there, that the industry really needs to start adopting a more manufacturing style of running projects. And I think that's exactly what needs to happen here. In a production line, what you do is take samples at high frequency, not just of the product, but all the moving parts of the machine. And at the early signals of something going off track, you adjust. A very agile workflow. You don't ruin the entire batch by not paying attention. And of course, a building project is not a production line, but I want to show you how this type of systematic workflows can be implemented in practice. And this is an example of a workflow that we typically help our customers implement in all their projects. This is a weekly cycle. It really could be any duration you like, but weekly is more than enough for most projects. We normally start with step 0 before the construction begins, just to set everything up with all the participants. Step 1 is about synchronizing the building plans with the platform. Step 2, the on-site teams start making scans and submitting it online to be inspected by the platform in step 3. Everything that is not according to the plans is reported to the team leaders in step 4, who need to essentially decide what to do. And there's virtually 2 choices they can make. Either the issue is not acceptable, pinging the contractor to resolve the issue on site under 5A, or we leave things as they are, it has no impact on the project, we're not going to rework, but instead the design team is notified they need to update the BIM models so that they're always as built. And I want to show you how this works. I want to go very quickly through the cycle with you. Uploading the BIM models is as simple as drag and drop. If you're running BIM projects, you have all the information you need in your computer to upload this. These are the models that come out of the planning stage. And in a few moments, you can see on the platform in the 3D viewer what was uploaded. What I'm showing you here is a BIM model of our new office in Oslo. We just took over a couple weeks ago. And of course, the first thing we did was to make a BIM model out of it with furniture. And here's a quick tour of our new home. So the platform is now ready to receive 3D scans. And these are done with any off-the-shelf equipment. And these things are getting cheaper year after year. You press one button, the data is uploaded. And here's you can see a scan of our office. And in the platform, you can merge the real data from the scans with the virtual furniture, for example, and create this type of mixed environments. But you'll notice that the 3D data lands in the right place automatically in the BIM model, which is extremely handy. And you can navigate this data just like a 3D game, but you also have 360 panoramas like this, like Google Maps, which gives our users a lot of insight of what's happening out there on the job site. So the data is now ready for inspection, and the computer is going to look at the specification, the tolerances, the schedules for the different disciplines. In this example, it flags in red a few columns that are either missing or misplaced according to the BIM model. And it's going to create a report out of these objects to send to the relevant discipline leaders, who receive this information in step 4. And they can review the details, they have different insights, so they are very quick at deciding what to do. In this case, column move to the left 32 centimeters. They can also access the 3D data to take any measurements they want, discuss with their colleagues. In this case, they're going to commission a BIM update. We're not going to tear down the column. There's a whole building sitting on top. Much easier to do a design update. And when all the issues are processed, they're now flagged as in progress. So in this example, the contractor is off the hook, but the designer instead picks up the hot potato to do a design update. And the first thing he does is to export the relevant scans to his computer. This is all open data, which means you can use any software tools you like. He also exports the reports with all the details and the instructions, what needs to be done. And in this example, he's using ArchiCAD as his design environment. He could be using Revit or any other tools you like, and simply uploads the data in there. So when he loads the scans, again, they land in the right place because they share the same coordinates as the BIM model. And when he uploads the report, you can see what needs to be done. And he just drags the objects around until they match the real world position. 32 centimeters to the left. And again. And when everything is in the right place, he saves the file. And that's it. The BIM model is now as built. He goes back to the platform to close the issues. The issue is resolved. He signs. And when he's done, all the issues are marked as resolved. And that's it. So at the end of the week, all the new BIM updates are re-uploaded back into the platform. The BIM model is always as built, and the cycle starts over. Again, week after week. I also want to point out step number 4. This is the area where all our users want to spend their time. These are smart people, educated, trained. They want to spend time solving problems, finding solutions. They don't want to be walking around on site trying to find the issues in the first place. Those are non-value adding tasks that can be automated, so they can focus on what really matters. And we've implemented this in a small project, 600 square meter refurbishments, all the way to some of the biggest projects in Norway with several 100,000 square meters. The results are very interesting, and I wanted to show you just a handful of my favorite examples and our learnings. And I want to start here. This is a very cool example, very early in the structural building phase. The computer found a problem with that opening in the wall in the center of the image. And I want to see if any of you can spot the problem. So by flagging that opening in the wall was misplaced to the right by a few meters, of course, the contractor is notified, they messed up. But the immediate consequence of that misplacement is the clash with the upcoming ventilation equipment team. So if this hadn't been reported this early, the most likely scenario is that the ventilation team arrives and surprise, they can't do their job. And now they are idle. You have one team having downtime. Their bosses, the engineers, are now doing over hours to solve this problem in as least time as possible. Should the contractor close that opening and open a new one in the original position? Should we reroute the ventilation equipment to go through the new position of the opening? That might affect the energy efficiency of the building the way it was planned. And you need to do all these decisions under pressure. So the timing of finding these issues early has a magnitude of impact in the cost-saving potential. This example is also very cool because it shows how we can solve a problem before it happens. And what's happening here, there's a wall on site. This is a concrete casted wall, according to the plans. And what we see in the 3D scan data, these little objects here are reinforcement rebar, these metal rods coming out of the floor. And the contractor team was about to bring up the casts to start casting this wall. The computer flagged that because this location is a very low tolerance place, it's the entrance to an elevator shaft. So everything needs to be very well within tolerance. It flagged that a few of the rebar were too long. In other words, if they casted the wall, they would have made a too long wall. Since this was flagged early, it's so easy for the contractor to just cut them, instead of having to cut the wall after it's casted. We see this a lot. This is a different setting. We see a lot of projects going in the direction of modular and off-site construction, prefabricated, as a way to avoid the on-site and increase productivity, which is great. However, it puts a lot of pressure on making sure that the interfaces are correct. Things need to fit like Lego. And in this example, the whole top floor of the building, all the columns, all the ceilings, the roofing, was prefabricated. And we saw on the data that the foundation for the columns were all misplaced, which means when the columns on site, they will never fit. Everything needs to go back to the drawing board. And it's so easy to fix well in advance of the equipment arriving. And we can do other cool things with the data while we're checking the position of the columns and the openings in the wall. Why not check if the floor is flat? This is a height map. Essentially, the areas in green are a few millimeters lower than zero. The blue ones are a few millimeters higher than zero, their elevations. And this is an area where there will be water on site. So there's a drain in the center of this room where the water needs to flow out. And the computer flagged all those areas in green around the center as water pockets. The water will accumulate there. And it takes 2 minutes to get this data. And today, you know how this is done with a ruler with a bubble in the middle. So for the contractor, this is very easy to fix, either by adding cement or sanding out the areas in the elevations in blue. But if this had been overlooked, on the other hand, the owner could be stuck with damage to the concrete floor slab decades after the handover. Terribly more expensive to fix than now, during the construction phase. And I just want to show this example because it's by far the most common. These are clashes in the technical disciplines. And essentially, what happens is somebody installs something in the wrong place without realizing that they're occupying the space that was reserved to the next discipline. So again, the next discipline arrives, they can't install things as they should, they're idle, or they're going to improvise. And trust me, these guys are stubborn. They're going to find a solution. But again, without realizing there might be compounding on the problem. But when this is reported early, it's so easy to put things as they should be or adjust the building plans. And this is my last example. What happens at handover? This is a brand new building, has been just finished and delivered to the owner to start the operations. This is a scan of a complex engineering room down in the basement. This is as built. I mean, if you travel, that's what you're going to see. And this is the documentation that was provided to the owner. Does anybody notice anything? So imagine you're the owner. Again, you don't have access to the scans, let's say. You have to operate this building based on the documentation that was submitted to you, right? You're screwed. So you hire somebody to go on site and install a smart sensor in this orange pipe. But what pipe, right? So when it's presented like this, it's a matter of minutes for a designer to just move things around and put them in the right place once you know where the deviations are. So I want to finish with the results. I'm very proud of this slide. Almost 100% of the issues reported by the system were previously unknown to the project teams. There was no registry in the issue tracker, mainly as a result of the speed and the high frequency. There's no way to have that efficiency manually. And because of the, so it's a more efficient way of finding the problems, of course. But because of the details in the data, the context, people just look at these images and they know what they're looking at. There's no need to go on site and have a big discussion, which means the teams themselves become much more productive and can resolve 3 to 6 times more issues per hour than the current way of working with schematics and thousands of photos to go through. And again, because you can visit the site virtually by logging into the platform, you don't need to travel, which means if you're missing a measurement, if you want to take a screenshot, you can do it from your desk. 2 travels a week on average per person that had access to the digital twin are no longer needed, right? So I hope this is, in our minds, a testament of how the industry will be changing in the next 5 years as these technologies become a standard in all job sites. I hope you found this insightful. That's what I had for today. Thank you so much.